Great. Okay, so this is a practice final. Okay, so let's take a look. The practice final says that, okay, good. So 60% of the final comes from the materials after midterm. So that's going to be modules 5, 6, 7, 8, 9. And the other 40 comes from the before midterm. So question 0 here asks you to redo the Cengage online assignments, the examples in the lecture slides. Okay, so if you are under time constraint, you know, for example, if you haven't started, the first thing you want to do is you want to, I think we are covering practice final today. So what you're going to do next is you want to go over, okay, I would recommend you to go over the exercise from the meeting sections. So that's going to be the meetings. Okay, so weekly meetings. You want to try those problems there, weekly meetings. And the next one you want to do is you want to do practice midterm. And then what you're going to do is you want to check out all the quizzes, which should also be open for you. Okay, you should be able to see them. I think you should be able to see the question. If you are not, do let me know. And then you want to check out the graded Cengage assignment, graded assignments. And then you try the ungraded one. Right. Okay. I think this is going to be the order of a priority. I would recommend my students to do it. Great. And okay, so let's get started with the very first one. Okay, the very first one. Okay. So yes.
Yeah, I just wanted to double check. We're allowed a note card or something like that?
Yes, you are. You are. It's a make sure you go over the Canvas. I think there's a study guide or final information on Canvas. Make sure you go over that one. You are allowed for by one note card, double-sided, 5x8, right? 5x8. Okay. So I think okay. Let's see. So I have 6 students. I'm probably gonna put you guys in 2 breakout rooms this time, and you guys probably just want to quickly go over one. And so you, okay. So you know what? I think I want to let's read the question first, and then I'm gonna put you guys in breakout room because I want to show you how this can be simply done instead of you guys just start talking and probably it's gonna take a lot of time. Right, okay. So let's quickly go over the question. At least we are able to pinpoint which type of question, what kind of data it is, right? It's gonna help you save a lot of time because it has been a while for us to go over this type of problem. We were talking about NOVA, chi-square, and those kind of things. But question 1 is something that we have done a while ago. Okay, so let's take a look. So question 1, okay. So you want to rate it first. Okay, so let's see. So you want to rate it. So they were talking about hotel rooms in Florida, and it is very important for the economy of Florida. Okay, so there are 2 years, 2015 versus 2014, and you have occupied rooms versus total rooms, right? Okay, by looking at this number, it looks somewhat like a numerical data because I have seen, you know, quantities measurements, the total number of occupied rooms versus total rooms, right? So those looks like numbers, numerical data. Okay, but you want to think carefully. So for example, the first question, what is the point estimate of the change in the proportion of rooms, right? So this is definitely a keyword you guys should highlight. Okay, proportion of rooms. So it looks like it's dealing with proportions. If it's dealing with proportion, what do you think? What kind of data do you think it is? Is it numerical data or is it categorical data?
Categorical.
Categorical data, right? It's a categorical data. And the next thing you want to think about is, so I'm going to go back to the flow chart I made. So this is a categorical data. So if it's a categorical data, you have to think about, you know, how many populations we have. Is it 1, 2, or maybe more than 2? We are comparing 2 years, right? So it's going to be 2 populations. It's going to be a z-test. You see, this is fairly clearly is a z-test. Okay, so, and we want to go back to what we have. So the next question A says, what is the point estimate of a change of proportion rooms? So I think what we want to do here is we're talking about proportion of rooms. And the question A asks for the point estimate. So typically we put a hat on the estimate, right, on estimate. So part A asks for estimate and part B asks for confidence interval. So from those 2 questions, I should be able to see this is actually nothing but an estimation problem. It is not a hypothesis testing if you go. The next one, so those are the keywords I see, formulate a hypothesis test. So this is a hypothesis testing, right? Okay, so once you figure out the type of question, all you need to do is you want to see which formula to use. It's going to be much easier that way. Okay, so let's take a look. So we know it's a categorical data, and we know it's a two population. We are looking for point estimate, that's right here. You will also ask for confidence interval, right? Okay, and next question you were asked to set up a hypothesis test. So it's going to be a z-test, and so that's the formula right here. So it's fairly straightforward, right? Okay, not very tricky. Okay, good. Okay, so I want to get my students thinking. Okay, good. So what is the correlation you guys got?
The R squared is 0.16, and then you square that to get your index. So we got 0.4 or 40%.
You take a square root of that. I guess that's what you meant. You take a square root of.
Oh, yes. Sorry.
No, that's okay. Yes, okay. So I've already mentioned in the second breakout room, I want to say over here for everyone. Okay, so in this question, okay, we know it from the question, it is a positive correlation. The reason is because, okay, so let's take a look. The question says if you attend a higher percentage of classes, if you go to classes more regularly, you are more likely to have a higher grades. So hopefully everyone agree with me, the correlation is positive. This is for this particular question. In general, a correlation could be both positive or negative. It's just going to be anywhere between plus minus 1. Whereas on the other hand side, the R square is always between 0 and 1. Okay, we know it is a positive correlation for this particular question. We also know the R square is 16%. So now we're going to solve for correlation. I'm going to call it X. So we know X squared is 0.16. So what is the value of X? Right? So the X here, it could be positive 0.40. It could also be a negative 0.40. You can try, you can use your calculator. You should be able to verify a negative 40. If you square it, you also get a 0.16. But for this particular question, we are going to use the positive one because we know a positive class attendance gives us positive higher grades, right? Okay, but for some other contexts, the problem may be different. For example, in the final, you may see a negative correlation and you should choose a negative 40%. Is this part clear how I talk about this? If you only know the R square, you will not tell right away whether it's a positive or negative because both of them are going to give you the same R square. It is very important you know whether it's a positive relationship or negative relationship. So you want to look carefully the context of the question. Okay, excellent. I think given the limited amount of time we have, I probably want to cover question 4 here. For questions we were not able to cover in today's review session, the solutions are provided. Make sure you try them first before you look through the solution. Okay, so let's take a look at question 4. Okay, so let's take a, maybe you guys want to read it first and we can work on part A. Okay, so this is a multiple choice question for part A. And I want you guys to read it first and tell me, is your answer A, B, or maybe C, right? So questions you always want to ask yourself, is this numerical data or categorical data? How many populations are there? I think it's clear it is 2 populations because I also labeled for you it's population 1 versus population 2, right? Okay, now you want to think about it. This is related with how much they spend on credit card, right? So is this numerical data or is it categorical data? This is related with how much they spend, not whether they are using the credit card for dining out or maybe for grocery. It is how much they spend. It's the actual amount. So it is numerical data, right? Would you agree it is numerical data? Numerical data. Okay. So after you're done, maybe you can tell me, is this a 2-sample z-test, 2-sample t-test, or maybe paired t-test?
Paired.
Jackson said parity test. How about Sarah? Do you agree with him? Paired, okay. Kenan?
I have no idea.
Okay, so you have three choices. So whether the first A and B are for independent tests, right? Is a independent t-test or independent z-test. The last choice C, is a paired test. Okay, so let's take a look at the question. So I'm going to use my highlighter to highlight. So there's a keyword I'm looking for. So assuming each account was used to identify for grocery and then also again for dining out. So we are comparing, we selected 40 credit card here. So 40 credit card. So for each account, I'm going to see how much they spend on grocery and then how much again spend on dining out. So the first number for grocery is for one particular individual. It could be Kenan. The second number is also how much Kenan spent on dining out, which is probably 0 for right now, given the pandemic situation, right? Okay, but he probably spent a lot on grocery. So you can see the first number, say $200 versus 0. Those are numbers related because they were all collected from Kenan's accounts. They are not independent. They are highly related, right? Kenan, do you see where I'm going? Okay, so I have three choices here, A, B, C. Do you think it's C, paired, dining out versus grocery? Those are related because they all came from one individual. So they are related, right? Not independent. So they are related. They are related. Okay, so let's go back to the formulas we used here. This is for numerical data. So as you can see, numerical data. Okay, and it is a paired test. Okay, match the sample or paired test. They are completely equivalent, exchangeable for this class. And I think for part B, we would have to carry out a hypothesis test. And the formulas are all given here. If it's an estimation, that's going to be this one. And the next page gives us the formula for t-test, right? So that's the formula here. So D0, again, D0 here is 0, right? Okay, so all you need to do is you want to plug in all those numbers here. Okay, so those information actually are given to us in the question. So let's take a look. Okay, before I show you you guys my working, so let's take a look. So suppose we are using difference data. So that means for each individual, for example, I'm going to use Kenan's account, as we were saying. We were able to collect Kenan's how much he spent on grocery versus how much he spent on dining out. We take a difference, right? We take a difference. And then we know the average difference. That means out of those 40 people, 40 accounts, one of them is Kenan. And we were able to figure out the sample difference as a D, which is 850. Okay, so 850. Okay, I think there's a typo. I'm gonna fix this one. This should be D bar. I'm missing a bar. Okay, D bar. And so we have the D bar. So this will be helpful for us. We have this part ready. And we are looking for SD and sample size. Okay, so we also know the sample standard deviation is this much. And the sample size is nothing but 42, right? And so you want to carry out a test. It's going to be fairly straightforward. I'm going to write it out. So first thing is the question says you want to write out hypothesis statement. That means you want to write out a null and alternative. So that's going to be here. Okay, why is it a two-tailed test? Why is it a two-tailed test? Okay, the reason is because part A, it says you just want to figure out whether there's a difference or not. I'm not talking about whether you spend more on grocery versus dining out. I don't know whether it's a positive or negative difference. I'm just looking for a significant difference. So that's why we want to use a two-tailed test, And then you're going to set up the test statistic, which is going to be t-score. Okay, this part is easy. This is the formula I copied from the formula page here. Make sure you guys print out this 4-page paper formula for your final on Thursday, right? So I just plug everything in here. I just plug it in. That's going to be a t-score. Okay, and I did the calculation. Just plug all the numbers in. which is 4.9052. So I try to carry as many decimals as possible. I mean, I wouldn't say as possible, but maybe four, at least 4 decimals. So that's 4.9052. Okay, and I will set up the degrees. I will find the degrees of freedom. This is nothing but a sample size minus 1, 42 minus 1, that's 42 minus 1, that's 41. So this part is straightforward. Okay, the next step, I like to show you how to do it. So what we want to do here is we want to find a p-value, right? I want to do it. Maybe some of you have already seen it, but bear with me. This is probably going to be the last time I'm going to show you guys. Well, we are coming towards the end of the term, right? So I'm going to show you how to find a p-value in case some of the students are still puzzled. Okay, so first thing you notice, this is a two-tailed test. This is a two-tailed test. So what I could do is a t-curve. Excellent drawing. I hope you guys by now are also expert on drawing curves after taking this, right? I hope you are. I hope you are. Okay, so this is a t-curve of 41 degrees of freedom. It is right here, that's a 0. Okay, regardless whether it's a z or t, it is always centered at 0. It is only for chi-square or f. It's going to be asymmetric and it's going to start from 0. It started from 0. You cannot get negative values. Okay, so what we have here is we know the test statistic. The test statistic is 4.9052. That's the number I just found right here, right? Okay, so what we want to do here is we want to figure out the p-value. Okay, I have just remind you guys, it is a two-tailed test. So when you find two-tailed test, you want to shade this upper tail. You also want to shade a corresponding lower tail for the corresponding lower counterpart, which is minus 4.9052. That's going to be this versus that. So if you are looking for the p-value, that's going to be 2 times this small corner here, right? If you find this part, you just have to double it to get a total p-value. Okay, so now we have to figure out this one. And so that's going to be to the right-hand side, to the right-hand side of a 4.9052, degrees of freedom 41. Okay, so let's go back to our t-table. Okay, and so that's the second table we learned. Also, this is a chi-square. I was wrong, 42. T distribution, 42, 41 degrees of freedom right here. We are looking for 4.96. Okay, 4.96. Well, the largest one I see is 2.710. So 4.96 is just gonna be here. Yeah, I don't remember. Is it 4.961? Okay. So you can see for upper tail, this one is going to be 0.005. This should be less 0.005, right? It should be less than that. Is this part clear? Okay. So let's go back to the question we were working on. So we know it is less than 0.005. You double it, it becomes p-value less than 0.01. I make sure you double it, right? 5% you double it becomes 0.5% you double it becomes 1%. So it's less than 1%. So the p-value is less than 1%, fairly small. You want to compare with alpha, which is 5%, you are going to reject. You're going to reject it. Are you going to claim how much you spend on grocery versus how much you spend on dining out is not the same. It is not the same, especially nowadays. You probably spend $0 on dining out, but you guys spend a lot on groceries, right?